Okay, so we're going to talk about the secondary illumination. And as Erwan was discussing in the first presentation in this session, that strictly kind of was discussing what we would call as the primary illumination or the direct illumination. Here, what we are going to do is to go one step further and talk about the secondary illumination, which actually gets into the PSRs and allows imaging and also controls the basically the climate, if you may, within the PSR. So next slide, please. Okay, so why this particular presentation is kind of concerned specifically with the peak near Shackleton site, but this is just a case study. What the more focus for this particular talk is actually about the secondary illumination itself and why its dynamic behavior is something of concern and importance. So this particular site is also one of the 6 in this 13 named, which actually overlaps a PSR with an area in the range of 5 to 10 square kilometers. Larger PSRs are actually more probable to actually host regions which can actually trap volatiles. So this was one of the ideologies we went through, but as I said earlier, this is just a case study. And we picked the 6 sites and then which actually had PSRs of this size range, and then picked one for this particular talk. This site is also located near an illumination peak. If you, in Erwan's presentation, I think it was the 8th one in the series that he was showing, you could see that there was a peak of light even during winter at this particular site. And to actually have a place where you have strong illumination even in the winter, while you still have a PSR, it's particularly a good situation, as a starting hypothesis of a good site. So why this particular direction of this case study? Well, we want to discuss the importance of the dynamic nature of the secondary illumination in the context of these candidate sites. From the sample collection and the EVA perspective, the understanding the dynamic nature can directly influence decision making. And if you were to look into the science definition report, I'd see especially for this investigation 2C1 and 2A3, this is actually kind of called out with respect to temperature. And why is the timing correct for this kind of thing? We have a mission ongoing with the KPLO spacecraft, also known as the Lunar in the local language, which has a camera called ShadowCam, which is actually imaging the PSRs. So at this point, it actually gives us a window into looking at the dynamic illumination within the PSR at multiple times. Next slide, please. Okay, so what is secondary illumination? Secondary illumination is the light that bounces off from the walls of an illuminated zone in the PSR. And it is that illumination which actually allows us to take images like this. This is an image where the insides of the PSR, the images that you see, those are from the narrow angle, the LRO narrow angle camera, long exposure images. So, that small faint amount of light which is still there can allow us to image if we image for quite long. Next slide, please. So just a basic simple schematic. You have the incident solar light coming in and it's bouncing off the primary illumination is bouncing off the crater wall, and it is getting into the PSR where you have the secondary scattered illumination. And that's a very simple schematic which basically shows this. Now, instead of that one ray, now consider a number of rays depending on the size of those small pixels that you see. So, all of those are actually bouncing from different points, and they're coming and illuminating the PSR. Next slide, please. So secondary illumination actually allows us to actually take images like this. The 2 images that you see there are from the ShadowCam instrument. You can also see them in more detail as a featured image from ShadowCam. And the light that you see there is completely secondary illumination, and that's how we could take those images. On the right hand side, there's a small picture of our camera, and below that is this KPLO spacecraft. Next slide, please. Okay, so let's just kind of look over at, think a bit about the dynamic aspect of the secondary illumination. The dynamic aspect of the secondary illumination arises because the sun is moving around, it's bobbing up and down the horizon as it is going around. So there are two distinct directions for this, and which are, we can track them as subsolar latitude and subsolar longitude. Now, while it does this, what happens is then the primary illumination, the main solar ray, it depends on time. It depends on the position of the sun. And it also depends on the large-scale topography around a permanently shadowed region. So we are not right now talking about the topography within the permanently shadowed region. But once it bounces and you get this secondary illumination, then it depends on the location of the exact PSR, and it depends on the topography inside the PSR. So you kind of have multiple things which control the way the illumination behaves within the PSR. And you can have, as I show that on the small cartoon on the left-hand side, the small and large moderations by the local topography. So say, for example, the region which immediately gets that secondary bounced light will be way more illuminated than a place which is shadowed due to small local topographic extensions. Next slide, please. Okay, so just another example. This is for the Marvin crater, and which is part of this connecting ridge extension Artemis landing site. You can see the location of the PSR, and in the background you can see the NAC mosaic. Next slide, please. So for that, we actually here we have a shadow cam image which actually shows the arrow shows the direction of the direct illumination, and that bounces off into the PSR, which is at the floor and a little bit on the wall of the other side. Next slide, please. So this is another example where another picture showing the same Marvin crater and the PSR below. Next slide, please. So this one is again kind of a zoom in into this, and you can see this thing in our featured images. If you look into that, you'll see multiple levels where you have contrast boundaries. And the arrows basically point to a contrast boundary which, unless you check it by topography, and if you have topography at that scale, then you will not really understand whether that topography is, whether that contrast boundary is real or not, because it can just be because of shadows. And as I mentioned earlier, the lighting here is extremely complex, so you can get to see contrast boundaries which may really say nothing. So we need more images from different directions in order to eliminate that kind of thing. Next slide, please. So basically, coming back to the slide which you were presenting earlier, so what we have due to the secondary illumination is a patchy illumination which varies dynamically. And this results in the thermal conditions varying dynamically within the PSRs. Next slide, please. Okay, so coming back to the site that we wanted to talk about. So this is the peak near Shackleton the panel B basically shows the NAC mosaic with the outlines of the PSR, and panel C basically shows the diviner temperatures and then the PSR. If you look into the PSR, you can actually see the temperature is quite consistent throughout. Next slide, please. So the PSR, this particular case, is very uniquely placed at an elevation. It is wedged between this small depression on top of a peak. And you can see right on the right-hand side, you can see this bright spot, which actually shows the peak of illumination at that point. And the outlines that you see were the same ones that Air One actually had shown earlier. Next slide, please. So again, on the left-hand side, you have the NAC mosaic with the PSR location. On the right-hand side, there's a slope map, which basically shows that the slopes across this region are lower than 15 degrees. And at different points, you can actually have traverse paths which actually go through 10 degrees. So it is a PSR. And the outlines for this is done in such a way that it is only 5 kilometers from the rim of the PSR. So you can think about a 2-kilometer position where you can start the traverse and get up to the rim of the PSR. Next slide, please. Okay, so this one is a modeled secondary illumination. So on the left-hand side is the model shown with respect to the radiance, and on the right-hand side is a grayscale version of that. You can see in the model itself, you can see the craters there. Next slide, please. Okay, so the temperature here is the maximum temperature are less than 100 K throughout, and the coldest pixel is somewhere close to 65 degrees. It could be a really good cold trap for water. Next slide, please. So this screenshot actually shows the maximum sublimation rates of the PSR, and you can see the lowest sublimation rate occur on the right side, which are the yellow pixels. where you also predict the lowest irradiance levels. Next slide, please. Okay, this is a couple of panels which actually shows the change in the PSR illumination, secondary illumination throughout. And as you can see on the first panel and on the fifth panel, you can see it actually indicates 0, where there is no illumination. But on the third one, top right, you can see that the geology also. Next slide, please. So this plot actually shows the primary and the secondary illumination irradiance levels, where you can see the primary illumination is really, really high, and its orders of magnitude, it's about 10 to the power 3, 10 to the power 2 to 10 to the power 3 orders of magnitude difference. Next slide, please. But when we zoom in into that one particular cycle, this was done for subsolar latitude of 1.5, we can actually see that there is a lot of change within the dynamic range for the secondary illumination. And there are 2 timestamps there which I put in for a hypothetical time of like Jan 16th, where you simulated this. And we can see that it changes throughout. So even
less than a minute.
So even though the primary illumination doesn't change a lot, the secondary illumination does change a lot. Next slide, please. Can you play this, please? Oh, can you play there's a video on the previous slide. Previous slide. Previous slide. Can you play the video, please? Okay.
Doesn't look like it.
Yeah, I don't think we can play the video in this one.
That's fine. That's fine. Let's move on to the next slide, please. Okay. So what we're waiting for are images like this, basically, which shows both the primary illumination on the right side, on the left side, and the shadow cam image on the left side. Let's go to the conclusion slide, please. Okay, so the dynamic behavior of the illumination of the PSR is an important consideration towards exploration. Dynamic behavior can be directly analyzed for the Artemis III candidate sites by images from shadow cam acquired multiple times. For the particular site, the peak near Shackleton has a PSR with area of 5 square kilometers and over, and has relatively stable dynamic illumination. The illumination changes by orders of magnitude diurnally, but the average around which this fluctuation occurs is low. Temperatures are less than 100 K over the entire PSR, and the slopes are low across this region. And I complete with saying that this was just a case study. This is actually a small part of the larger study that we are going to present soon, and across multiple PSRs for the Artemis III candidate sites. With that, I can conclude my talk. Thank you.